Good afternoon, everyone. Very happy to be here to talk about a story that Netflix, we have solved the problem of delivering content into our content hub management system using Snowball Edge. About 18 years ago, the founder of Netflix have done some calculations. It would take roughly 5 days to download a full-length movie, but it only takes 3 days to mail a DVD. And that worked. 18 years later, we have again the same challenge. My name is Zio Liao. I'm a software engineer at Netflix in the content platform engineering team. Today, I'm here with Brandon Businger, who's our product manager. He's responsible for setting product goals, visions, defining business workflows, and also provide domain knowledge. I'm going to hand over to him to talk about the challenge we have today.
Thanks, Zyle. Hi, everyone. I'm Brandon Businger. I'm a product manager in Netflix's production product organization, where we focus on the problems of our studio organization and its productions. So like Zyle said, DVDs were a great solution to an internet bottleneck. That's not a completely unique idea. Around the same time, in 2002, Jim Gray and a team at Microsoft published a paper called Terascale SneakerNet, where they identified that given current network conditions, most large-scale data transfers, at that point terabyte scale, would continue to make more sense to move on hard drives. They also, in that paper, propose that moving forward, while their current network problems would be solved in time, the actual scale of the data loads was going to raise exponentially as well, and so they anticipated that the same thing was going to hold true moving forward. Turned out that was true. So since the days of DVD, Netflix has made some new bets, most notably forming a studio to produce content. And in 2015, we had launched 100 original titles with the greatest talent in Hollywood, from David Fincher to Genji Cohen. And over the next few years, over the next few years, we realized we had a problem. It was growing. It was growing really, really fast. And the numbers of titles we were launching each year was getting staggering. So, why is that a problem? It's great for the business, but it produces some other unexpected challenges. Now, I don't know how many people here have worked on a production, but over the course of a single production, when you start in development and you're doing storyboards and concept art, you move into production and capture the original footage. You move into post-production, where you do editorial, visual effects, sound. And then finally into finishing, where you master, color grade, title, and finally deliver the content to go onto the Netflix service. You produce a good amount of data, a lot of data. On a single production, say Bright, you would be anywhere, you would probably be at the 1 petabyte scale. On a smaller production, you might be at 300 terabytes if everybody's only shooting the stuff that needs to be in the movie. That never happens. So in reality, what that happens to be is when you break that down by the number of content hours we produce, by the number of terabytes per content hour, great, so we get a really, really, really big number in 1 year. So what are we going to do about that? We had already built a content management system, but we didn't know was how are we going to get everything into it? It's a lot of titles to get onto the internet. And productions weren't helping. I don't know, again, how many people have worked on production, but productions are all over the world. Netflix has titles shooting everywhere. A film like Okja, shot in South Korea, then moved to Vancouver, then did post-production in Los Angeles, visual effects in India. It's all over the world, and they don't stay in any one place for very long. That makes a problem for internet. Even further, they don't have IT departments. So moving things over the internet is not something that they naturally do. Changing a bit, but largely. We also had another problem. These are the current data management solution. So what were we going to do about it? We knew this wasn't going to work, but we looked back at what our founder did 20 years ago. We looked at what Microsoft had talked about, and we said, hey, that's a pretty good idea. Maybe that's going to hold true. So we looked around and said, well, what do we need? DVD's not going to work. It doesn't hold enough data. And there's a bunch of stuff about a production that's just kind of unique to shooting a movie. So we looked around at what our options were, and we said, well, what do we need? You see, when you're producing a show, our producers don't have time to wait around if a unit doesn't get there in time, if it won't boot up, if it crashes, if it moves slow. These are just non-starters for a production environment. So we needed something that ticked all of these boxes. We took a look at Amazon Snowball Edge that had come out right around that time, and we said, hey, that ticks quite a few of those boxes on paper. Let's get one in, put it through its paces, and see what happens. On first test, it actually did pretty good, but we still had a lot of work to do. You see, it wasn't moving fast enough. It wasn't in enough countries. We had a few other problems that we really needed to work through before it was really going to solve our problem. So we worked with the Amazon product team to address some of the issues of reliability, and they came back to us with great solutions. We started rolling it out across the world, adding new countries, and since then have launched it on 40 titles worldwide. But even with all of that problem solved, we still had a problem. It wasn't fast enough, and it wasn't so easy that David Fincher could use it. He's actually pretty smart. He'd probably figure it out. So I'm going to hand it over to Zyle, and he's going to talk about what him and our engineering team did to solve the problems of integration with our cloud production systems and the speed and security issues that we still had with deploying it in the field. Zyle?
Thank you. So before I start, I'd like to define some of the entities or roles in our workflow. Of course, we should have a Netflix title. And title is a placeholder for all the assets that our vendors or productions promise to deliver. And those assets will be delivered into a Netflix system called Content Hub. It's a workflow management system. It's an asset management system. And it's managed by our operational team down in LA. And then we also have vendors, external third-party companies, also production users, who is going to use this system to deliver their assets, their products, into our Content Hub repository. Of course, in today's use case is AWS Snowball Edge. I don't know how many of you have seen the Snowball Edge before. It basically is just a big, huge desktop computer with tons of CPU and storage. For a 100 terabyte box, you have probably around 90 terabyte of usable volumes that you can store your custom files. At the back of the device, there are 3 network interfaces. RJ45, 10 gigabit switch that's the speed, the maximum speed allowed. And then if you want to go QSFP plus, you can go up to 45 gigabits per second. It also runs a S3 service, a subset of the S3 service, where you can use the AWS CLI S3 copy command to directly copy files into this box. So I'm going to talk about an oversimplified workflow. Just give you guys an overview of how this workflow works. So Netflix will order a Snowball for a vendor. And we use AWS Snowball API with all the instructions. And AWS will prepare appliance and deliver that appliance to the vendor location. And vendor or production users, whoever they are, will use the Snowball to transfer their local storage, local content onto the Snowball. Once that is done, the Snowball will be then shipped back to AWS data center, where a predefined S3 bucket will be loaded with the content on the Snowball. From that point on, Netflix will take the content from the S3 bucket and put it into our internal system, make it available for all the downstream consumers. Of course, all this would not be made possible without the hard work of my friends and colleagues at Netflix. Let's dive a little bit deeper, dive in a little bit deeper. We have a webpage where our folks down in LA is able to use to order a Snowball. And this is a component, a web page developed by our UI teams. A user will typically enter the recipient, name, address, phone number, and country. Country is very important here because we use the country to map to a specific AWS data center. With that data center, now we can put all the related resources associated with the Snowball. The S3 bucket name, the SNS topic, the KMS encryption keys, and also the AMI rows. Once the link is built and they click the submit button, it starts the life cycle of the Snowball. As you can see from the screen, AWS Console provides a very detailed state of the Snowball. It can tell you at the current moment where the Snowball is. Is it just created, or is it being prepared, or is it on the row, in the row to be shipped to the customer, or it is with the customer? For every state change, AWS sends us an SNS event. And we have an email service that listens to those events. And we enrich the event with our project ID, our title name, and the list of recipients that want to receive the email, and also a link to our Content Hub system. That way, they know exactly where the job is and at what stage. Now, the Snowball is delivered to the vendor or to our production users. What are you going to do about it? Well, AWS provides an out-of-box Snowball client for them to do the copying. They need to download from the AWS console the unlock code and the manifest file to unlock the device. Once the device is unlocked, they can use the AWS CLI S3 copy command to copy all the contents, transfer all the contents from local to the Snowball. But that's not going to work for us. Why? Because Brandon just defined a bunch of requirements. For example, security. We're not going to allow external or third-party vendors to log into our AWS account to download the manifest. If we do that, I'm sure our security team will scream at us. And AWS 3 has a limitation. I think today is the maximum object size cannot be more than 5 terabytes. I think it was lower a few years ago. But we cannot force our users to say, you have to use a smaller file size. So we have to handle that use case. And that's another requirement, non-functional requirements we get. Performance. If you just use the AWS CLI to do the S3 copy, you probably get a 100 megabyte per second throughput. And that's not fast enough for most of our vendors. They're very demanding. And also, I have a 100 terabyte job I need to deliver to Netflix. And after I transfer 90 terabytes, and there's a power outage. And I don't want to restart from the beginning. So our vendor requires that we have the ability to resume from the last checkpoint. And with all this requirement, it makes sense for us to create our own CLI. And that's what you see in the screen. Our CLI is composed of many server-side components because we have so many requirements. The client cannot just do it alone. It needs support from the backend service. So we have all the clients to make API calls to the backend. We also leverage the AWS Snowball Client because it has the proprietary code to unlock the device. And it also comes with the JVM. And therefore, our Java code or JVM code can run on top of the existing AWS Snowball Client. How does that all work? Well, first, our vendors or external users need to be onboarded into a Netflix user account. So we have an onboarding service. Once a user is successfully onboarded, they are issued a user credential and a client ID and client secret for the vendor. If you know the terms, you probably guess this is a standard OAuth authentication protocol. So now the user's onboarded into our account system. With the credential, they are going to send those credentials to our token service. By the way, our vendor account database is called Edward, and the token service is called Mitchum. I don't know if anybody knows who Edward Mitchum is. He is the bodyguard of House of Cards. It's one of my favorite shows. If you have time, you can go back and watch it. So with that, we handle the security, the authentication part. The successful authentication will return user an OAuth 2 token, a bearer token. That token will be sent to all the downstream services to verify the identity of the user. Now we need to see now we know who this person is. We also need to know what this person is authorized for. And that Content Hub service does that. It will return all the movies titles that this person is authorized for, along with the manifest unlock code that this person has for a particular snowball that was ordered for him or her. With that, the user can now unlock the box. But before the copying starts, we also have to verify that the content they have is valid. As Brendan mentioned, it is very critical for us to make sure that the content is 100% correct. Otherwise, we might have to go back, to the production to remake a few seconds or minutes of shots. And that's very expensive, sometimes even impossible. So in order to do that, we ask our vendors to run checksum to ensure that the file they promised to deliver is the file that we're going to get. With that, we also take a snapshot of the entire source content from user's local storage and replicate that to our server side using the Cloud Drive service. That gives our users a visual representation of the content they have in their local storage. Finally, we get to the copying part. Because of the security requirement or the size requirement, for every file, we go to the server to obtain an encryption key. Trunk the file, if it's larger than a threshold, into smaller parts, and encrypt every part and send that to the Snowball individually. I don't know if you can see this screen is probably too small. On the left-hand side is actually the CLI. Once you enter your credential, you see a list of projects, and then the unlock code is downloaded, and use that to unlock the box. And then you will scan all the local storage files and folders and copy that over to the right, which is a visual representation on the server side of your local content. If your eye is good, you might see there is a tiny blue circle on the bottom right corner. It just represents that this file is just a placeholder. It's not materialized yet. Once the Snowball is shipped to AWS and the files are copied over to the S3 bucket, this spinner will be gone to show that this file is activated, it's available for downstream consumption. On the server side, once the vendor finished the copying and copy all the files to the S3 bucket, for every file that it dropped to the bucket, and separate SNS messages sent. And our secure storage service will listen to those messages. And once it detects that all parts of the file are present in the S3 bucket, it will run the process to stitch them together and materialize it. At the same time, it will also run multiple algorithms to calculate the hash. Access hash, MD5, SHA-256, SHA-1. We have more in the future to support. As those files are processed, again, it will send a notification to our Cloud Drive service, where it will put all the files that is materialized into the active mode, so they can be used by downstream consumers. And we also have multiple listeners to the Snowball event. Once all the files contents from the Snowball are copied to the S3, we will send a final notification to our users via email to telling them your content is ready. Now you can follow the business workflow for the next step. Next, I'm going to talk about some of the challenges we have developing the CLI because of requirements that Brandon has laid out before. Right? One of the biggest one is performance. How do we go over and above 100 megabytes per second? Is that even good? Can we go 300? Can we go 500 megabytes per second? Can we even go to 800 megabytes per second? And we have been spending a lot of time to achieve that. In the beginning, we started with, let's do our security requirement. Right? We read a file, take a chunk of that bytes into memory, do the encryption and trunking as necessary, and then send it to the Snowball. And then we've done that. And the performance was not great. So we say, oh, what can we do? Easy, right? We parallelize the operation, make it more threads to do upload at the same time. And that indeed increased the throughput. But that's not enough. Because we find out when we do that, the CPU is saturated. The workstation that we test with has 100% CPU. It's probably too busy doing the memory swapping, and it doesn't do the actual job. So we figure we need a more powerful machine. Right now, we recommend our vendors and users to have at least a 12-core Mac Pro. But the faster the machine, the more powerful the machine, the faster the throughput. But still, not enough. Now we have a powerful machine, but the throughput is still not ideal. What else can we do? We later find out the process is not optimized. We read some bytes into memory and then write it out to Snowball. While the read happens, the write is not happening. While the write happens, the read is not happening. We can probably optimize on that. So we divide the operation into two separate thread pools. So the read and write can be done at the same time. And that's exactly what we do. And that seems to work well in the beginning. But then we bump into another problem. The read is much faster than write, because if you have attached storage, it's much faster than the write, if you especially have an SSD. And what happened is that the buffer gets bigger and bigger, because the writer is not fast enough to take the bytes into Snowball. And eventually, we're running out of memory. So there's a lot of tuning. How many reader threads we should have? Given a hard disk with a 7,200 RPM, with a certain number of physical read head, we figure 4 to 8 threads probably is the best. And how much memory do we need? What is the threshold for the trunking of our files? Because that whole trunk can be loaded into the memory. And how much impact does it have on the CPU side? With all those parameters on the fly, it's up to us to come up with the right parameters to turn the performance for all the vendors out there, and we don't know what kind of machine they have, what kind of network they have. So those are the challenges we face. All we can do right now is come up with a very common and general set of configurations that most people can benefit from that. I'm going to also talk about challenges on the server side. One of the biggest problems that we've seen since that we went live with the Snowball was to ensure 100% completeness. Right? We also have the terms. What's the chance this error is going to happen? 1 out of a million? That could be a legit statement in most cases, but not in ours. 1 out of a million means failure. We cannot take 1 out of a million. We have the guarantee. Doesn't matter if it's 100 million or whatever. We have to guarantee every file that's in Snowball should be ended up in our asset management system 100%. We have done multiple things to ensure that. We ask our clients, vendors or users, to take a checksum in the beginning. With the checksum, we know exactly how many files and what the file size and their hash. But what if they add more files to the Snowball without a checksum? Sometimes we may have a use case to allow that. So we, again, have to take a snapshot of the entire local storage and dump into our server side. As a redundancy, we also dump it onto the Snowball itself. So once everything is received on the server side, we make sure everything matches. Everything matches each other. For example, once the files receive from the S3 storage into our secure storage will send an SNM message to our client, our cloud service, to say, this is the file I received, and this is the checksum. And our cloud service will verify that checksum against the snapshot. And if that match, we're good. And we also have a challenge of handle multi-region problem, because our production happens everywhere in the world. We now support US region, the 3 US region, Canada, Brazil, Japan, India, Western Europe, and we're going to start Australia soon. To handle all those resources is not a trivial task. Right now, we have to do manual setup. The S3 buckets have to be defined. The AMI roles has to be assigned. The KMS key has to be created. And along that, we still have a lot of internal services to listen to all those events. And sometimes we don't know, should we deploy the service near the data center, the local data center, or to set up replication around the world. It really depends on the use case that Brandon's going to provide us. So those are a big challenge for us. And lastly, we have operational challenges. The user can misuse the Snowball client and ask us, hey, I don't see the files. Where are they? So DevOps engineers spend a lot of time to dig into all those questions. And there's really no good solution other than more tooling, better process, so that all these missing files, corrupted files, can be self-healed. With all that, what can we do next? Snowball, a couple of months ago, the Snowball team tell us that they have an AMI version for the Snowball Edge. You can put your own AMI image into the Snowball. That way, the vendors don't need to have their own workstations. You just directly connect the Snowball into the storage, into the network, boom, you're ready to copy. So that helps the vendor a lot, especially they're small or medium size. We also have a use case where, for example, we're working on House of Cards Season 5, right? And the editors might want to refer to some of the assets in Season 4 and bring that asset to their local storage. And AWS Snowball has also an export functionality where you can map your S3 bucket or certain files in that bucket onto the Snowball. And the Snowball will be shipped to the editorial facilities. So that's definitely one of the use cases we want to explore. We also want to see if Snowball can help with our onset workflows. Typically, for our Snowball job, it would take a week to 2 to complete from beginning to end, depending how large the data set is. But our production onset usage might require much shorter turnaround time. And those are the challenges our product team is trying to solve in the coming quarter. With that, thank you for coming, and I can take some questions if you have any. All right. Thank you for coming. And don't forget to take the survey.
We can do questions from
if you can do
Mike
you
there
can do
if you want.
question there.
I have a question. Right now, we're doing not as big as you, but content delivery to aircraft using all our own stuff. And one of the objections that our team has raised is the cost of moving all this large quantities of data through Amazon. And I don't know how much you can share, but what's your experience with moving all this amount of data through Amazon, and how much does using Amazon save you in terms of the alternative of having your own infrastructure and equipment?
Yeah, I can speak a little bit to that. I can't give you exact numbers, but it's a lot, as you saw from the fuzzy math up front. What we found in the production space was because the production industry has moved from photochemical processes and highly manual processes over the years, that the sort of accounting methods that we used, it was very unclear exactly how much money was being spent on storage when you add in all the soft cost. Power, physical footprint, potential risk, all of those things. So we did some basic math of, okay, well, what do we think if we would set some baseline of managing this data well and said, how much would that cost locally? And if we had to replicate that this many times, it very quickly became obvious that we couldn't. You were going to cut corners somewhere. There wasn't enough staff that understood how to manage that kind of data. The infrastructure wasn't there, which meant that we just assumed people were cutting corners. And so we made the bet that having a standardized process or a much more manageable process had a lot of soft cost benefit to us that outweighed the kind of specific, hard dollar line item cost, because that wasn't an apples to apples comparison.
Okay, that was helpful. If I could ask another question, if there's none other. So you've talked about optimizing the speed transfers out of the Snowball and into the Snowball. Can you tell us how fast have you gotten it to go?
So in our lab, we went up to 900 megabytes per second. Megabytes.
Very good.
On a 10 gig.
On a 10 gig network.
Yeah.
You haven't tried their faster network connections?
No, I haven't yet.
Yeah.
I think they're still working on an SDK to support that kind of bandwidth.
Yeah. The challenge with the 40 is that from a single client, you often just don't have the cores to handle the,
When you mentioned the checksumming that you guys were doing, it sounded like you were using generally cryptographically strong hashes on that. Did you do any science on expected data rates or error rates of using less expensive hash functions to see if you could get that data processed or checksummed faster?
So yeah, we chose XS hash over MD5 because the speed probably the same, but it consumes a lot less resources.
Yeah. There's a bit there too that part of this is because there's a transaction going on. It acts as a chain of custody, which is the sort of added value there. So it's the production statement of these are the files I intended to transfer, and then for the system to be able to tell them with confidence, the files that we have are the files that you stated you were intending to send.
Any other questions? All right. Thank you very much for coming.